FluidFlow offers a fast and effective approach to automatically size piping and key equipment in transporting fluids, such as controllers, boosters, flow elements such as orifice and venturis, as well as relief valves. The succeeding slides will guide users to the Autosize features of these components. Take note that, except for pipe components, the automatic sizing feature is normally turned off when a specific component is being rated on its performance in a system. Firstly, let's explore pipe sizing with FluidFlow. FluidFlow can suggest appropriate pipe size using its Autosize function. The software can automatically size a pipe or duct based on any of the following methods: economic velocity, by velocity, or by pressure gradient. The economic velocity is a function of the physical properties of the fluid being transported, the pipe materials, various capital and installation costs, and other variables. This value is calculated automatically by the software using the values and constants stored in the pipe sizing database. Economic velocity is changing over time, particularly as energy costs significantly vary through the years. Thus, it is important that default values are updated regularly. This can be done by keeping the software regularly updated or by manually updating the pipe sizing database. If the by velocity option is selected, an additional entry for design velocity appears. This allows users to set the design velocity for the piping system. Upon hitting Calculate with this option engaged, the solver can show the exact velocity size, which is the exact pipe diameter required, based on the defined velocity. Users can opt to update the current pipe size input with this proposed size, or select the closest and most appropriate standard size available. If the by pressure gradient option is selected, an additional entry for design pressure gradient appears. This allows users to set the design pressure gradient for the piping system. Upon hitting Calculate with this option engaged, the solver can show the exact pressure gradient size, which is the exact pipe diameter required based on the defined pressure gradient. Users can opt to update the current pipe size input with this proposed size or select the closest and most appropriate standard size available. Next, let's see how to auto-size control valves. Engineers can automatically size control valves to ISA standard 75.0101-2007. Controllers such as self-acting pressure reducer, sustainer, or differential pressure controllers, as well as flow and pressure control valves, can be auto-sized in FluidFlow. Setting the automatic sizing feature on will engage users to select the desired control valve type and define appropriate setting, without the need to access the database. Now, let's move on to sizing boosters in FluidFlow. Boosters can also be auto-sized by FluidFlow. When the automatic sizing feature is on for booster components, which impart velocity to a fluid such as a centrifugal pump or a fan or compressor component, the element can be automatically sized based on design flow or pressure rise. Positive displacement type boosters, on the other hand, can be automatically sized based on design flow. When the sizing model is set to Size for Flow, the software will calculate the required booster differential pressure needed to meet the system flow. On the other hand, setting the sizing model to Size for Pressure Rise will calculate the attainable flow based on system resistance. When the automatic sizing feature is turned off, users will need to select the appropriate pump, compressor, blower, or fan model available in the database. If not available, users may add new information to the database as needed. Following that, we'll look at how to auto-size flow elements. Flow elements, such as orifices, nozzles, and venturis, can be auto-sized in FluidFlow. Orifice in FluidFlow can either be thin or thick plate types. For measuring devices, thin orifice plates are commonly used. Thick plate orifice can also be used for measuring devices, but aside from that, they are also used as restriction to reduce pressure and balance flow to a network. When the automatic size function is engaged, users can select which sizing model will be used for any of these types, either by flow or pressure loss. Automatic sizing of nozzles can be made using sizing models for flow or pressure loss. Using any of these sizing methods, ISO 5167 or long radius nozzle equations can be applied as preferred by users. Lastly, venturis can be autosized based on sizing models for flow or pressure loss. Once the autosizing function is engaged, the software would be able to determine the required throat diameter on the specified conditions. Similar to boosters, for any of these components mentioned, setting the sizing model to size for flow will calculate the required orifice or throat diameter needed to meet the system flow. On the other hand, setting the sizing model to size for pressure loss will calculate the attainable flow based on system resistance. Lastly, let's discuss autosizing relief devices in FluidFlow. FluidFlow also allows users to automatically size relief valves for liquids, gases, steam, and two-phase systems according to API RP520 and ISO 4126-1 standards. Once the autosize function for the pressure safety valve is activated with the desired pressure loss model, the allowable overpressure, set pressure, design flow, and valve coefficients would need to be specified in order for the software to determine the required safety valve orifice size. We have just tackled the different equipment that can be automatically sized in FluidFlow. In the subsequent topic, we will focus on how to create connections through pipes, along with some important guidelines to consider when creating these connections.